Assalamualaikum. My team will talk about thermal heat for cooking pan. This idea is based on cooking pan, but we add an improvement. We end up putting an engineering material, which is phase change material, into the pan for better absorbing and releasing heat. This improvement will help the cooking to become faster and making the heat more stable when cooking and after cooking. Okay, now what is efficient heat transfer? Efficient heat transfer is critical in cooking because it ensure food is safe to eat while optimizing flavor, texture, and nutritional value. Efficient heat penetration ensure the core of food reaches required temperature to kill harmful enzyme. It also softens tough protein and fibrous structure, making them easier to chew and digest. And now we're moving on to the modification. What is PCM? Because this pan is integrated phase change material, which is PCM. This material is based on engineering material that basically help in absorbing and releasing large amount of energy when they change phase. This allows the pan to charge with heat, store it and release it, evenly back into food even after the stove is turned down or switched off. Okay, that's all from me. Now we're moving on to Anissa Hayat.
So now let's move on to problem statements. So the first problem statement is the heat is not distributed evenly. The second one is the heat is lost quickly. And our last problem statement is it reduced cooking performance. Next is I will talk about our objectives. So the first objective is to improve heat storage so the frying pan can maintain its temperature for a longer time. The second one is to ensure heat is distributed evenly across the cooking surface. And the last one is to improve cooking performance by producing more evenly cooked food.
And now I will explain the material layers used in a normal frying pan and compare them with our proposed thermal core pan. First, let's look at the normal frying pan. A normal frying pan is made up of several layers, and each layer has a specific function. The first layer is a non-stick coating, the second layer is stainless steel, third layer is the aluminum core, and the final layer is a stainless steel induction base. Although a normal pan transfers heat efficiently, it loses heat quickly when cold food is placed on it. As a result, the cooking temperature drops and more energy is needed to heat the pan again. Now, let's look at our thermal core pan. The first two layers remain the same, the non-stick coating and stainless steel cooking surface, which provides safe cooking and durability. The next layer is the copper. Its purpose is to distribute heat rapidly and evenly throughout the pan. Our main innovation is the phase change material, or PCM layer. This layer stores excess thermal energy while the pan is heating up. This helps maintain a more stable cooking temperature and reduces the amount of extra energy needed from the stove. Finally, we add an insulation layer at the bottom of the pan. This layer reduces heat loss to the surroundings, making the pan more energy efficient. By adding a PCM layer for thermal energy storage and an insulation layer to reduce heat loss, these modifications help maintain a stable cooking temperature, improve heat transfer efficiency, save energy, and produce more evenly cooked food. Let's explain how phase change material works. The phase change material is layered beneath the cooking surface. When the pan touches the heat from the stove, heat travels through the metal by conduction. Then, the pan reaches a high temperature when the PCM begins to melt. Whilst melting, PCM absorbs a large amount of heat without an increase in the temperature. This stored energy is called as latent heat, which is a concept in physics. When cold food is placed on the pan, PCM begins to solidify and the extra heat helps maintain the cooking temperature. This eventually helps the food cooks more evenly.
The main thermal physics concepts used in the thermal core pan are conduction, radiation, and latent heat. First, heat from the stove is transferred through the metal band by conduction. The pan also gains and loses heat through radiation, where infrared waves transfer thermal energy without heating a medium. Inside the pan is a phase change material, or PCM. When the pan becomes hot, the PCM melts and absorbs a large amount of heat without increasing in the temperature. The stored energy is called latent heat. When cooked food is placed on the pan, the PCM solidify and release the stored heat, helping to maintain a stable cooking temperature and allowing the food to cook more evenly. The physics question used. First, heat energy. That question is Q equals to MC delta T. Where Q heat energy equals to joule, M equals to mass kilogram, C is specific heat capacity, joule kilogram negative 1, Darjah Celsius negative 1, and delta T is temperature change. This equation which calculate the heat needed to change temperature. For the second one, latent heat. The equation is Q equals to ml, where Q heat energy is joule, mass is mass kilogram, L is specific latent heat, joule per kilogram.
Now I will explain the advantages of our thermal storage frying pan. The first advantage is more even heat distribution. The thermal storage material helps spread heat uniformly across the pan, reducing hot spots and allowing food to cook more evenly without burning. Secondly, it is more energy efficient. Since the pan stores heat and releases it gradually, less energy is needed to maintain the cooking temperature, helping users save electricity or gas. Another advantage is that it maintains a stable cooking temperature. Even when cold ingredients are added, the temperature does not drop drastically, resulting in more consistent cooking. In addition, the retained heat can reduce cooking time, making food preparation faster and more efficient. Finally, the improved heat management reduces thermal stress on the pan, making it more durable and less likely to warp compared to conventional frying pan. Overall, these advantages make the thermal storage frying pan a more efficient, reliable, and sustainable cooking solution. Now, I will explain the target users of our thermal storage frying pan. Firstly, this frying pan is suitable for home cooks and families because it provides even heat distribution, making everyday cooking easier and more energy efficient. It is also ideal for professional chefs and restaurant operators, as the stable cooking temperature helps produce consistent food quality during busy cooking hours. In addition, students and individuals living alone can benefit from this product because it reduces cooking time and helps save electricity or gas. The frying pan is also suitable for elderly users as its heat retention reduces the need for frequent stove adjustment, making cooking more convenient. Finally, this product is designed for environmentally conscious consumers who want to reduce energy consumption and adopt more sustainable cooking practice. Therefore, the thermal storage frying pan is suitable for a wide range of users, from everyday household to professional kitchens. In conclusion, the thermal core pan improves cooking performance by combining the principles of heat conduction, radiation, and latent heat storage through phase change material. This innovative design stores excess heat and releases it gradually, ensuring more even heat distribution, stable cooking temperatures, and better energy efficiency. As a result, food cooks more evenly and cooking time is reduced so that less energy is wasted. Overall, the thermal core pan demonstrates how thermal physics concept can be applied to develop practical, efficient, and sustainable cookware for everyday use.